right, so this is section 6.7, graphing linear inequalities with two variables. So a linear inequality with two variables is the result of replacing the equal sign in a linear equation with an inequality sign. Okay, so the first thing we're going to look at is tell whether the ordered pair is a solution of the equation or the inequality. So what we're going to do is substitute the ordered pair for x and y. So we would have -0 plus 2 times 0 and see if that's less than 8. So -0 plus 2 times 0 would be what? 0. So 0 is in fact less than 8. So this would be a solution to that inequality. Okay, so if we do this again with the next problem, we're substituting 0, 4. So -0 plus 2 times 4 is less than 8. So -0 plus 8 would be 8, and 8 is less than 8.
So no solution?
Yeah, so this one isn't true. No solution. Okay, so some of you have already started on the next one. We're going to substitute 3 for x and 5 for y. So -3 plus 2 times 5 is less than 8. What would that equal? So that's -3 plus 7, or -3 plus 10. Will get you 7. 7 is less than 8. So that is a solution.
So you just put a check mark?
Yep. Or a yes, or a solution. You can do any of those things. Okay, so graphing an inequality with two variables, you are graphing a set of points that represent all the solutions for the inequality. So these graphs are divided into two planes. Only one half of the graph is going to contain solutions. The other half would not be a solution. Okay, that'll make more sense here in a minute. So when we graph inequalities, we are going to graph them like we did linear equations. We're going to solve for y if we need to, and then we're going to graph it just like we've done equations. So you can either make an XY chart, you can graph using slope and intercept. That would be my preferred choice for this, is use slope and intercept. It's a lot faster than an XY chart. And that's the way I would graph these, unless it was like too difficult for me to do that method. So what we're going to do after that is we're going to check our boundary line. So if you have a dash, so mark this in there, this should be solid, not dash. So fix that on your notes. You don't have any of this. Okay, well, we're going to go over it anyway. So if it is greater than or less than, it is going to be a dashed line. If it's greater than or equal to or less than or equal to, it's going to be a solid line every time, okay? So then we're going to graph it, and then we're going to check it, and once we check it, if it is a solution, then we'll shade that. And this, like I said, will all make more sense here in a little bit. So we're going to graph this inequality. Y is greater than 4x minus 3. I would choose, so y is already isolated. That's in slope-intercept form, right? Like y equals mx plus b. I would choose to graph this using my intercept and then my slope, personally. So y is greater than 4x minus 3. So I'm going to graph my intercept first. Which one is my intercept? -3. So I'm going to put a point at -3. And then I'm going to do what with my slope? Up 4, right 1. Up 4, right 1. Up 4, right 1. Okay, don't draw a line yet. Just do your 3 points. And then this is a greater than symbol. So this has to be a dashed line, not a solid line. So you're going to just draw in a dashed line. So what that means is it doesn't include anything on that line.
Okay.
Yes,
Why is there a point at 1, 1?
because I went up 4, right 1.
Oh, yeah, okay. Thank you.
So this means that nothing on this line would be a solution to this inequality. It wouldn't work. Okay, so what we have to do is we have to test the inequality to see which side to shade. So I personally like to choose easy numbers to work with, like 0, 0, or 1, 1. But you can't choose anything that is on your line. So 1, 1 I cannot choose for this problem because 1, 1 is a coordinate. But I can choose 0, 0. So I'm going to test 0, 0. And what I'm going to do is plug it in for x and y. So 0 is greater than 4 times 0 minus 3. So what would that equal? 0 is greater than negative 3. And is that true? Okay, so you are going to shade the side that is true. So 0, 0 is true, meaning I'm going to shade that whole left side. So I'm going to shade the left side of my inequality. So that means that anything on that left side of the inequality would be a solution to this inequality. Okay. All right, so we're going to go to the next one, and we're just going to go through this process and keep practicing it. So x plus 2y is less than or equal to 0 is what we're graphing. So I need to do some rearranging to this equation before I can graph it, or this inequality. So what should I do first?
Minus x.
Subtract x from both sides. So then I have 2y is less than or equal to negative x. And then I have one more step. Divide both sides by 2. So y is less than or equal to, and I'm going to go ahead and write that as negative 1/2 x. Okay, what is my intercept?
Negative 100.
That's my slope.
Oh, my bad.
My intercept is what? 0. So I'm going to put a point at 0.
Yeah.
And then I'm either going to go down 1, right 2, or I have to go up 1, left 2. So down 1, right 2, and then I'm going to go up 1, left 2 to get enough points. Okay, so now this time, this is a solid line because this is a less than or equal to. So I'm going to draw a solid line through. Okay, so now I need to test it. I can't use 0, 0 this time because our graph goes through 0, 0, but I can use 1, 1. So I'm going to plug in 1, 1. You can either plug it into the second inequality or the original. It doesn't really matter. So 1 is less than or equal to negative 1/2 times 1. So that would be 1 is less than or equal to negative 1/2. Is that true? That is not true. So I need to shade not the side with 1, 1. I need to shade the other side of the graph. So I need to shade this part of the graph. Okay, so we're going to do the next one together. X plus 3y is greater than or equal to negative 6. So I have to first start out by subtracting x. So 3y is greater than or equal to negative x minus 6. And then I have to divide everything by 3. So y is greater than or equal to negative 1/3 x minus 2. Okay, so I'm going to start by graphing my intercept at negative 2. And then I'm either going down 1, right 3, or up 1, left 3. So down 1, right 3. And then this would be a solid or dash? Solid. Okay, so this time when I go to test it, I can use 0, 0 because 0, 0 isn't on the line. So I'm going to use that because that's easier. So 0 is greater than or equal to negative 1/3 times 0 minus 2. So 0 is greater than or equal to negative 2, which is true. So I'm going to shade the part of the line that has 0, 0. Okay, so I want you guys to try this one on your own. So you'll need to pause your video and graph this. Okay, so it should be a dashed line, and I can use 0, 0 because that's not on my line, or you could use 1, 1. So 0 is greater than 3 times 0 plus 1. 0 is greater than 1. So that is not true. So I need to shade the other side of my graph. And that's what yours should look like. Okay. I want you to do the next one as well. So pause your video and graph this. Okay, so to graph this problem, I would start by subtracting x, and then I would have 4y is greater than negative x minus 8. And then I need to divide everything by 4. So I have y is greater than negative 1/4 x minus 2. So then I'm going to plot my intercept at negative 2. And I can either go down 1 or right 4, or I can go up 1, left 4. And this is a dashed line. And then if I test 0, 0, I have 0 is greater than negative 1/4 to the 0 minus 2. So 0 is greater than negative 2, which is true. So I'm going to shade that side. Whoa. Okay, so let's go through the next one. All right, so 4x plus 10y is greater than or equal to 20. So my first step would be what? Subtract 4x. So 10y is greater than or equal to negative 4x plus 20. Then I need to divide everything by 10. So y is greater than or equal to, and then I'm going to go ahead and simplify this fraction to negative 2/5 x plus 2. So I'm going to plot my intercept at positive 2. Then I have to go down 2 and right 5, or up 2 and left 5. And this is a solid line. And then I'm going to test 0, 0. So 0 greater than or equal to negative 2/5 times 0 plus 2. 0 is greater than or equal to 2. So that's not true. So I got a shade above. Okay, so we just have 2 graphs left, and we don't even have to, it doesn't take much to graph them. So the first one is y is greater than 3. Okay, so does anybody remember what a y graph looks like? A straight line straight across, horizontal. So this one is going to be dashed, going all the way across 3. Okay, so then I still need to test it in shade. So if I plug in 0, 0 is greater than 3, which is not true. So I'm going to shade above. Okay, so then on the last one, I have a graph with x. So I have x is less than 1. So this is a vertical line going up and down at 1, and it's dashed. So again, I'm going to pick 0 to test. 0 is less than 1, which is true. So I'm going to shade to the left. Okay, so on your homework assignment, you're going to have graph paper with it. There is a lot of graphing, obviously, and I would recommend that you, I think it's easier to continue shading like you've been doing with your colors and everything. So your homework assignment is textbook page 409.